One. Hello, everyone. We are R3-Cooler, Team 1. My name is Abhishek Jasti. I am a senior at Cal State Long Beach, currently majoring in computer engineering and minoring in computer science.
Hello, everybody. My name is Adnan Jasti. I'm also a senior at Cal State Long Beach, majoring in computer engineering and minoring in computer science.
Hello, everyone. My name is Andres Garcia. I'm a fifth-year computer engineering major with a minor in applied math.
Hello, my name is Ethan Dixon. I am a fourth-year computer engineering undergrad.
And then, hi, my name's Emily. I'm also a senior at Cal State Long Beach studying computer engineering.
Our product name is R3-Cooler because it is a robot with 3 wheels and it has a cooler inside. Obviously, some of the features, as you can see, are listed. One is fully autonomous, avoids any obstacles that are in its way. 2, it has a refill alert to order more beverages and lets the owner know when to buy more beverages. And also, we do have an LCD screen on top of the R3-Cooler to display the rules of how to buy a beverage, how to open the lid, and also display the temperature inside the cooler. One of the biggest problems this project will eliminate is whenever you have a guest or a friend over at your house and when they rummage through your fridge trying to find the drink of their choice, they knock everything over. So instead of that, this R3-Cooler, this product, will bring the beverage and the drink to the guest or your friend. But some of the features, as you can see, we do want to implement, if time does permit, is a built-in speaker to have a party whenever you need to, and also a GPS tracking system to let the owner of the R3-Cooler know where the R3-Cooler is at all times. This is our design and block diagram.
So for the first major part, the refrigerator, there are several components to this. The first main one being the cooling system. We want to be able to control it, make sure it's able to go at least at or below 45 degrees. The lid motor to shut it up and down, and the lid sensing to make sure it's fully closed or fully open. The weight sensor just to detect how many drinks are in the device, the LCD to display what drinks are in there, and the camera to scan the QR codes.
And for the power system of the diagram, we're gonna have it's gonna be powered through battery, and then we have a charging for the battery, and then we also have power monitoring, usage of the battery, overcurrent detection, over voltage detection, and temperature detection for the power system.
And then for the motor, we have 2 wheels who will have motors, and then one will be a pivot wheel.
And for the tracking tech module, we do want to make sure that our R3-Cooler is fully autonomous and that it avoids any of the obstacles that are in its way. And also, like I've mentioned before, the GPS tracking system, if we do have time to implement, it would go in the tracking tech module.
The IoT module, it will take care of the mobile application that we plan to build. So it will allow the user to control the motors, update the LCD, show the exact location, and show the temperature and the battery status of the cooler. It will also be able to open and close the refrigerator safely from a distance. Some of the performance requirements that we plan to implement, since we're using Wi-Fi to communicate between the cooler and the mobile application, we want the Wi-Fi to be at least 300 feet of transmission range with less than 100 milliseconds delay, and the cooler should get at least less than 45 degrees Fahrenheit during all times of the operation, and it should last up to 10 hours. The charge time should be less than 5 hours, and the camera should support 1080p at 30 frames per second, and also the speed of the cooler should be greater than 4 miles per hour.
So these are all of our roles for this project. As for my role, I am in charge of the camera just to make sure it's able to read that QR data and send it to the app. And I'm also in charge of the weight sensors to determine how many drinks are in the device and if it needs a refill or not.
For my role, I'm in charge of the cooling system with responsibility of monitoring the temperature, as well as the power system for the power source, the charging battery, monitoring for the battery, the usage of the battery, overcurrent and over voltage detection, and temperature detection for the power system.
And then I'm in charge of the motor control, enough to hold 5 to 10 kilograms, as well as the R3-Cooler outer shell, which is going to be a combination of 3D printing and DIYing.
And like I mentioned before, I'm in charge of the tracking tech to make sure that our R3-Cooler is fully autonomous. And I'm also in charge of the lid sensing to make sure that the lid cooler is shut all the way, or when it needs to be opened, that it opens all the way. And I'm also in charge of the LCD to display the menu of beverages inside, display the rules of how to use the QR scanner, and also it displays the temperature of the cooler system inside.
And I'm in charge of the IoT, which interfaces between the R3-Cooler and the mobile application that we plan to build. And I'm also in charge of the lid motor, so I'll be in charge of taking care of opening and closing the refrigerator door safely from a distance. So for our microcontroller, we plan to and we are using the ESP32 board. Some of the features that this board has is that it has built-in Wi-Fi module that we could use, and it could be easily integrated with analog and digital sensors.
So this is the camera I've been currently testing with, called the AudioCam Mini. There have been a few issues with it. It's pretty finicky, works when it wants to and when it doesn't. In the future, I do plan to switch this camera to a Technogic, which is able to have IoT capabilities and should be able to scan QR codes much easier. And this is the weight sensor. It's fairly easy to use. It's just under ADC, but the only problem with the one on the right is that it's only able to hold 2 to 3 drinks. So in the future, I'm going to have to buy 3 or 4 more load sensors and put them all together to carry 12 drinks.
For the cooling system on the left, I have my setup. I was just doing a simple test for a thermoelectric module for the cooling system. In the middle, I have a simple schematic on how I plugged in my setup, and then on the right, I was able to reach as low as 43 degrees Fahrenheit. These are the parts that I will be using for the cooling system and the power system. I recently got parts for the power system this week, so over winter break, I should be able to mess around with them and see what I can do with it.
And then for the outer shell and wheel motors, the motors are seen on the right. There's 2 of them for the 2 wheels, and the gears are also seen. And then on the left, we see the Igloo 5-gallon, which we're most likely going to use for the outer shell of the R3 cooler.
And for the tracking tech, we are implementing the ultrasonic sensors. As you can see to the left is a schematic from our ESP32 board connect to one of the ultrasonic sensors. Obviously, it takes about 2 pins to connect to it. And in the middle, you can see the code, which I used to test 2 ultrasonic sensors facing in opposite directions to read distance value accurately, and which it does. So I created this schematic on the right to basically show potential points of where we could place a sensor on the R3 cooler. And for the lid sensing, I realized that our ESP32 board does come in with the built-in Hall effect sensor. So I was able to use that using the Arduino code, which as you can see on the left, our example code, and I was able to use it to get those values as you can see on the right, which when a magnet is detected, the values do rise above 100, and when the magnet is far away, the values do go below 100, or basically 50. And for our LCD, we were able to implement this code to get the background colors of the LCDs. As you can see, there's 3 different colors of the LCD. But one of the issues that we are running into is trying to figure out how to get text over the background color, which seems a bit of a challenge, but with the given time over the winter break, I think we will be able to do it.
And these are the parts that I plan to use to control the refrigerator door and to safely lock the refrigerator door. So for the locking mechanism, I will be using the electric magnetic lock, which can hold the door shut with 130 pounds of force. And to control the lid to open and close it, I'm going with this 12-volt motor that is small and compact and has high torque and low noise. And for the IoT application, I plan to use .NET MAUI to create the mobile application. And .NET MAUI is a cross-platform framework that can create native mobile apps for native mobile and desktop apps using C# and XAML. So we can use this to create Android and iOS apps for using a single code base. So for the communication between the microcontroller and the mobile application, the server service we're using is ThinkSpeak, and I have already created a simple LED on-off mobile application for our ESP32 controller, as you can see on the right.
And then for our project, we also have some ethical responsibilities and concerns. There are 3 of them. The first one, drunk driving, which is one of the biggest concerns that could arise with having a product that sells alcoholic beverages to consumers. And then a solution to this would be to have the owner buy a breathalyzer to check the blood alcohol content of a person who orders an alcoholic beverage. The second one, power consumption. At any point, the batteries can overheat and blow up. To prevent this, we want to implement a fan to cool down the system. And lastly, underage drinking. We currently do not have a solution for this, but we are still in the process of creating one.
So these are all of our costs. On the right, our professor did task us with coming up with our dream wages. So that is all of our desired wages to the right. To the left are going to be all the costs of the parts or items that we are going to have to use. In total, we do believe that this will add up to about $1,125, but this is not official yet.
And for verification and testing of our project for the Wi-Fi transmission range, our mobile phone will be used as a transmitter and the microcontroller will be the receiver. We'll be moving away the transmitter from the receiver until the noise/signal of the ratio reaches around 20 decibels. And for the refrigeration, we're going to place a thermometer inside of the refrigerator and leave it running until the battery dies and detect any dips in temperature. And then for the battery power, we're going to put our droid on autonomous mode and see how long it takes before the battery drains. And then for our charging time, it's just a simple test. We're going to plug it into the wall and see how long it takes to fully charge. And then for the speed of the droid, we want to make sure it's not too fast. We want to reach that speed of 4 miles an hour.
So for our fall schedule, this is what we were able to accomplish. The first 6 weeks, we were perfecting our ideas for this project, and it gave us clarity on what parts we were going to need. Week 7, we finalized our thoughts and ideas and selected the pieces. Week 8 and 9, each team member researched their responsibilities. Week 10 and 11, we designed our own perspective modules. Week 12 and 13, we bought the parts needed to prototype. Week 14 and 15, we built the prototype for each model. And then now week 16, we were testing the prototype. Now continuing on to next semester in the spring, week 1, we will refine the prototype from the previous semester. Week 2 and 3, put all the modules together and test the integrated system of prototypes. Week 4 and 5, design the actual product. Week 6 to 10, build the product. Week 11, test the prototype and make sure it supports the performance requirements. Week 12 and 13, refine the product design and make the required changes to the product. And the final weeks 14 and 16, we want to test a new refined product and get it ready for the Senior Expo.
And this is what you guys can expect for the Senior Expo. As you can see, I've listed off a couple of the main items you can see on the R3-Cooler. To the right, you can see a pixel art of our R3-Cooler of what it would look like. One of the biggest components that we do have is the camera, which can read the QR data from the user who buys a beverage, and also the LCD display, which will display the rules, display the menu, display the temperature of the cooler, and the cooler obviously inside has a weight sensor and cooling system to keep your beverages cold, and the weight sensor which can hold up to 5 to 10 kgs. And also it's fully autonomous, meaning it can avoid any obstacles that are in the way. And also we will be implementing the IoT app, which will allow us to let the user know what kind of beverages we do have, and also let the owner of the R3-Cooler know where the R3-Cooler is at all times. And here are some of the references. As you can see, many of them are YouTube links and Google links, which helped us work on our individual prototypes, and some are Amazon links, which are to the parts that we have bought so far. And thank you.